Okay, let's dive right into this explainer. We're going to take a seemingly random date in history and, well, turn it into a thrilling detective story about the world you're living in right this very second. You see, May 28th, it's not just another day on the calendar. On this exact date, across completely different centuries and countries, a handful of brilliant minds literally changed the reality we experience every day. So let's meet them.
What makes this single date so insanely powerful is how it connects these brilliant people who, quite literally, invented the architecture of our modern world. Now, don't worry, we aren't just going to stare at dry math formulas today. No way. We're going to see how these incredible mathematical ideas secretly run your daily life behind the scenes.
To see how this all built, let's start with a little journey to the year 2000. We're going to look at a piece of tech you probably used, well, just seconds ago, simply to load the screen you're looking at right now.
I want you to really think about this for a second. Have you ever wondered why your favorite music streaming apps sound so crystal clear, even when you're on a super slow connection? Or, say, how your social media apps manage to load millions of images incredibly fast without the whole entire system just crashing down?
Well, the answer takes us right back to May 28th, 2000. That's the day we lost a truly brilliant British physicist and mathematician named Donald Davies. Davies spent his time working on the very early development of computers and networks, and what he achieved? It fundamentally changed human communication forever. His absolute stroke of genius was this concept called packet switching. So instead of trying to send massive, clunky files all at once, which, would completely clog up the network, his mathematical logic takes your photos and emails and breaks them down into tiny, lightning-fast puzzle pieces. They all travel completely independently across the network, and then boom, they reassemble instantly on your friend's screen.
It's incredible to think about, but because of Davies, every single song you stream, every video you watch, every text you send, they're all riding on the invisible mathematical highways he designed. Without him, the internet, and ultimately the World Wide Web as we know it, just wouldn't exist.
All right, still on May 28th, but now we're going to jump way back to the year 1872. We're changing countries, heading over to Austria, and exploring a completely different, honestly, much wilder idea.
Have you ever watched a plume of smoke swirling up into the air, or maybe a massive crowd of people shuffling through a stadium, and wondered, is there some secret rule governing all this mess? I mean, to us, it just looks like total unpredictable chaos, doesn't it?
Well, we actually owe our understanding of that chaos to a guy named Marian Smoluchowski, who, you guessed it, was born on May 28, 1872. He was a real pioneer in statistical physics. He looked at completely random, chaotic physical movement, specifically this phenomenon called Brownian motion, and he somehow found the hidden mathematical rules hiding right inside it.
What's fascinating about Smoluchowski is that he was actually a world-class mountain climber. He was known for fearlessly taking on these impossible physical challenges, and he basically applied that exact same daring logic to science. He bridged this massive gap between messy physical randomness and beautiful predictable equations. By figuring out the theoretical explanation for how tiny particles just randomly bounce around in fluids and gases, he totally kicked open the door to the mathematics of stochastic processes.
It is just so incredibly inspiring to realize that the chaotic universe all around us, it's actually deeply structured. What looks like absolute pure chaos to our human eyes is, in reality, following a hidden mathematical dance. And Smoluchowski was the one who helped us finally see the steps to that dance.
Okay, same incredible date, but let's fast forward exactly 40 years. It's now 1912, and we're heading over to Germany to meet another genius who tackled a very, very different kind of puzzle.
Think about your normal, everyday life for a second and ask yourself, when you send a secure text to a friend, or say buy something online with your credit card, what exactly is stopping a hacker from just reading your data and stealing your information? Enter Hans Zassenhaus, born May 28, 1912. Aside from his brilliant mind, he was an incredibly principled man. He actually risked his career and his life by flat out refusing to join the Nazi Party, and he eventually used his skills to help hide endangered people. On the math side of things, his groundbreaking work in complex computational group theory, which deals with intense stuff like polynomial equations and prime factorization, that work literally became the absolute bedrock for how we process complex calculations today.
Zassenhaus essentially pioneered how modern computers handle really complex algebra. He figured out a method to calculate the deep, hidden properties of numbers using algorithms, and today, those exact kinds of complex algorithmic properties are exactly what computer systems use to scramble your private data. It acts like an unbreakable digital padlock for our most sensitive information.
Just think about that for a second. This highly abstract mathematical theory from decades ago is currently sitting right there, inside your pocket. Literally every secret you type is guarded by this invisible shield of algorithmic number theory. It's amazing.
So, zooming back out to look at this whole picture, it's wild to see how all of this beautifully builds together to create the highly connected reality we experience every single day. You've got Davies in 2000, Smoluchowski back in 1872, and Zassenhaus right there in the middle in 1912.
From the very internet you browse using packet switching, to those complex physical models predicting our chaotic weather, straight through to the secure messages you send shielded by complex algebra, every single one of these daily conveniences is a direct gift from these brilliant mathematical minds.
When you step back and look at the core takeaway from all these stories, a really beautiful theme emerges. Every single person we talked about today, across totally different centuries and countries, they all looked at a world that seemed totally disconnected, messy, or chaotic. But they all asked the exact same fundamental question: what is the beautiful mathematical pattern hiding inside?
We've just seen how finding these deeply hidden patterns literally built our modern world from the ground up, which leaves us with one final and honestly pretty exciting question for you to ponder as we wrap up this explainer. The universe is still absolutely full of secrets. So, what hidden mathematical patterns